Hi, today we're looking at solving polynomial equations algebraically as well as graphically. And the graphically component, we'll be going over how to solve them using the Texas Instrument graphing calculators. Okay, so to solve a polynomial algebraically, do it the same way as we did with quadratics in grade 11. We factor them, and then we look at our factors and determine what x values make our equation equal 0. So our first example is solve algebraically. We've got 2x cubed plus 3x squared minus 3x minus 2. So to factor this, we first have to look at our factors of our constant term. So that would be plus or minus 1 and plus or minus 2. So we'll start substituting those in for x to see which one gives us 0. So we'll try a is equal to 1. So we have 2 times 1 cubed plus 3 times 1 squared minus 3 times 1 minus 2. So 1 cubed is 1 times 2 is 2. Once again, 1 times 3, so that's 2 plus 3 is 5, minus 3 is 2, minus 2 is 0. So we know that x minus 1 is a factor. So I will divide that out of this using synthetic division. So we have our a value of 1, coefficients of 2, 3, negative 3, negative 2. We bring down this 2, multiply it by 1. Add these together, that gives us 5, multiply by 1. Add these together, that gives us 2, multiply by 1. As expected, this gives us 0, which we expect because that was a 0. So that gives us 2x squared plus 5x plus 2. We'll now factor this using a modified product sum from grade 11. So we've got a product that's 2 times 2, so 4, with a sum of 5. So we start each bracket with 2x. Two things that multiply to 4, add to 5 would be positive 4, positive 1. We can divide that to 2 out of one of this one. So that gives us overall x plus 2 times 2x plus 1 times x minus 1. So looking at this, our factors are x equals negative 2, or our zeros are negative 2, negative 1/2, as well as positive 1. Okay, so that was solving algebraically. If we want to solve it using the Texas Instrument graphing calculators, once we graph our function by pressing the y equals, entering our equation, and then pressing graph, we know that our zeros are the same as our x-intercepts because our y equals 0 when we have an x-intercept. Now, sometimes we'll also look for local maximums and minimums, but essentially to find our x-intercepts, once the equation is graphed, you can press second, which it tends to be yellow on the older Texas Instrument calculators, then calc, which is second from the top right. It's the button is shared with the trace function. And then once we do that, we scroll down to 0, press enter, and then it'll go back to graphing screen, but there'll be a cursor on our graph. We want to move that cursor to the left of where our x-intercept is, press enter. We then move it to right of where our x-intercept is, press enter twice. What this will do is it will find anywhere where our graph has a y value of 0 between those two boundaries, and then it displays that coordinate on the bottom of the screen. Now we have to make sure that we are only looking at one x-intercept at once. Now, to do our maximum minimum values, it's the exact same except for we choose maximum or minimum instead of 0. Okay, so we'll look at an example. A certain airline has regulations that state that the sum of length, width, and depth must not exceed 100 centimeters for carry-on luggage. Several models of carry-on luggage have a length 10 centimeters greater than their depth. Write a polynomial function to represent the volume and solve for the maximum volume. Okay, so to solve this, we need to know our volume of a rectangular prism, which is length times width times depth. And then we have to essentially get this down to two variables. Our volume we will use on our y-axis, and we'll get everything else in terms of x. So for example, if I say my length is equal to x, we're told our length is 10 centimeters greater than our depth. So therefore our depth would equal x minus 10, which would make our length 10 centimeters greater. Now, for the last dimension, our width is the harder one to get of these, but essentially we're told that the sum of length, width, and depth must not exceed 100 centimeters. So we have 100 is equal to our length plus our width plus our depth. So we have 100 equals x plus x minus 10 plus d. So we'll rearrange this, which gives us 110 minus 2x equals our depth. We now have every single variable from this equation in terms of x, so we can put those into our equation. So we have our length, which is x, times our width, and sorry, I made a mistake over here. I substituted my depth in for my width, so this should be my width. So now we will substitute our values in. So we've got 110 minus 2x times x minus 10. Okay, so now that we have our equation, we'll graph it. But before actually hitting graph, because it's probably not going to show up on our screen, because usually our screen is defaulted to from -10 to +10 for x and y, we have to figure out what value should be our x min or x max. So our x minimum doesn't make sense for us to, for example, have a negative length. So I'd say my x minimum is 0. So you can go press the window button on your calculator and set the minimum value to 0. The x maximum, looking at my equation, I know none of my lengths should end up being negative. Now, if I put a value in here that is any larger than 55, I end up with a negative. So I'll go x max is 55. Now my y minimum, it doesn't make sense to have a negative volume. So I'll start out at 0. My y max, I would probably set as, say, 100,000, because anytime we're doing a volume, we typically have fairly large values. Now, if I find it doesn't show up on my graph when I graph it, or goes off the graph, I'll just add another 0 to this. If it's super low and close to the bottom, I would just take away a 0. And then gradually fine tune the y max. Now, if I graph what's there, I should end up with something that looks something like this. At this point, we'll go second calculate. Because we're looking for maximum, we will move our cursor to the left of this maximum. So to here, hit enter. Move it to right of maximum. So for example, to here, hit enter twice. At this point, the cursor will have moved somewhere to center here, and at the bottom of the screen, it's giving the coordinate 38.58 and more digits, comma, 36,209. Actually, 210. Okay, so based off how we set these things up, we said y was our volume. So therefore, this is our maximum volume. Now we said our length was x, so this is our length at which that maximum volume occurs.